It was kind of like a geometry question. So it said like points A, B, C, and D lie on a line in that order, with AB equals CD and BC equals 12. We're given point E is not on the line and DE or BE equals CE equals 10. And we're given that the perimeter of triangle AED is twice the perimeter of triangle BEC. We want to find what is the length of AB. So I think let's talk about how you would do this problem. So this is like kind of a geometry problem. So you would want to like draw a diagram. So we're given in the first sentence that A, B, C, and D lie on a line in that order. So if you have like A, B, C, D, so like let's say you have this, so A, B, C, D, and we're given AB equals CD, so this length equals this length, and BC equals 12, and we have point E is not on the line, and BE, we're given that BE equals CE equals 10, and we're given that the perimeter of triangle AED, so that's kind of like this red triangle here, triangle AED, is twice the perimeter of triangle BEC, which is like this blue triangle here. And we know BE equals CE equals 10, so we should label those. And we want to like find what is the length of AB. So this is like a pretty like interesting question, right? So we're given that the perimeter of triangle AED is twice the perimeter of triangle BEC. So we can easily calculate that the perimeter of triangle BEC is just 10 plus 10 plus 12, which is 32. So we know that the perimeter of triangle AED is twice the perimeter of triangle BEC. So twice the perimeter of BEC is twice 32. So we know that the perimeter of triangle AED is going to be like 64. So the question asks us like, what is length of AB? So let's call like AB equal to X. We know that AB equals CD, so let's also call this X. And we know that like by symmetry, AE is going to equal DE, right? Because E is kind of like in the center of everything, like BE equals CE, and like A and D are also kind of symmetric. So we know AE and DE are going to be equal. Or you could alternatively prove that with like, if you want to be rigorous, you can prove that with something like, you know, SAS congruence. Like you can see that, you know, AB equals CD, BE equals CE, and angle ABE equals angle DCE. You can also prove it that way. But we find that AE and DE are equal. So if let's call these two lengths like Y or something. What we can do is I can kind of like draw this altitude downward. So I can draw from E down to BC. And since triangle BEC is isosceles, that's going to kind of like split line BC into like two things of length 6. We're going to split it in half. So if I were to call this height like h or something, I can use the Pythagorean theorem and get like h squared plus 6 squared equals 10 squared. So I get like h squared is 36, or 64, I mean. So you get h is equal to 8. So by Pythagorean theorem, we find that this length here is equal to 8. So now what we can do is we can like take a look at triangle. Okay, let's call this point like here, like let's call that point like P or something. We can take a look at triangle AEP, and we can use the Pythagorean theorem on that, right? So if we were to use the Pythagorean theorem on triangle AEP, the legs have lengths 8 and x plus 6, and the hypotenuse is y. So by Pythagorean theorem, you would have 8 squared plus x plus 6 squared equals y squared, right? Because like the legs are 8 and x plus 6, and the hypotenuse is y. And we're also given that the perimeter of triangle AED is equal to 64. So y plus y. So we know that the entire length here, this entire length, AD, is x plus 6 plus 6 plus x. That's 2x plus 12. So that means that the perimeter of triangle AED is going to be 2x plus 12 plus y. And that equals 64. We know that the perimeter has to equal 64. And then we can subtract 12 on both sides and combine the y. So 2x plus 2y, that is to equal like 52. So dividing by 2, we get x plus y is equal to 26. So now I can, from here, I can see that y is equal to 26 minus x. And then I can like take this and then I can plug it back into this equation up here. So if I were to do that, on the left side, 8 squared is like 64. And then you have x plus 6 squared. And that has to equal y squared, which is 26 minus x squared, right? Just by substitution. So we would have 64. And if you were to expand x plus 6 squared, we would get like x squared plus 12x plus 36, right? If you were to expand that out with like the distributive property or remembering like how that works. And then 26 minus x squared is going to equal 676 minus 52x plus x squared. So 676 is just 26 squared. If you were to like expand out the binomials. So conveniently, like the x squareds on both sides like cancel out. So now like we have like we can combine terms. So 64 and 36, that gives 100 plus 12x has to equal 676 minus 52x. So we can add 52x to both sides, and then we can subtract 100 on both sides. So 64x equals 576. And then we can divide by 64 on both sides. You get x is 576 over 64. And that simplifies to like 9. And then that would give you like choice D, which should be the right answer. Yeah, so just to briefly summarize like how this question works is like, remember like the idea is like whenever you have a geometry diagram, like basically you should always draw a diagram. Like don't try to like visualize everything in your head, because then you're gonna get confused and that's not gonna be good. So you should draw a diagram and then like clearly label it and make sure you know what you're doing. And in this case, like I guess the idea was like we started with information we knew, right? So they told us the perimeter of triangle AED is twice the perimeter of triangle BEC. So we know that the perimeter of BEC, we were able to find that easily, which was like 32 or something. And that means we know that perimeter of triangle AED, which is 64. And then from there, we just kind of like assign some variables. And then I guess like we use some Pythagorean theorem and the perimeter condition. And then with some like algebra manipulations, like you just carefully do your algebra and you should be able to like get the right answer.